Good evening, ladies and gentlemen. On behalf of Majan University College, I would like to welcome you all to this LITS webinar session. It is my pleasure to introduce the speaker of today's session, Dr. Renxi Qiu, who is a senior lecturer on computer science at the University of Bedfordshire, UK. He got BSc in Automatic Control Systems from University of Science and Technology, China, and PhD in System Engineering from Cardiff University, UK. Currently, he is the lead of Computing Cluster of University of Bedfordshire, the course coordinator for the BSc and MSc in Software Engineering, and Robotic Laboratory Manager at the Institute for Research in Applicable Computing. His research has been focused on the development and applications of semi-autonomous control frameworks which adjust robots' autonomy level based on situation. He was the coordinator of the first European project on semi-autonomous robot assistance for elderly care called SRS, with partners from 12 top research institutes across Europe. During the past years, Dr. Qiu has secured more than £1 million of external funding as principal investigator, co-principal investigator, or coordinator. Currently, he is the principal investigator for EU H2020 project, which is Micro Nano Robotics for Single Cancer Cells, and Innovation UK project, a cross-domain event analysis system based on transfer learning. His work on robotics has been presented in Europa House at Tokyo as a successful story of European robotics, and in House of the Lord at London for possible solutions of technology-supported living. He received Best Paper Award at 17th International Conference on Knowledge-Based and Intelligent Information and Engineering Systems, as well as Cotices Cognitive Robotics Best Paper Award finalist at IEEE RSJ International Conference on Intelligent Robots and Systems. So without further delay, I would like to invite Dr. Renxi to take over the session. Thank you very much and have a wonderful evening.
Okay, thank you very much. It's my pleasure to make the presentation on robotics for the webinar in Majan. My name is Renxi. I'm come from University of Bedfordshire, UK. Today, I'm going to talk about the topic of robotics. I will cover 3 topics in this talk. I will start with robotics nowadays, and then I will briefly talk about building robotic applications with robot operating system called ROS. And then finally, I will go through a project we had before building robot assistants using ROS. So that's the outline for our talk today. Start by robotics nowadays. The word robotics initially come from Asimov's science fiction book called Liar. And in that book, a robot trying to please his owner by lying to people. At the same time, robot have difficulties to maintain the consistency on his own knowledge because he's lying all the time. Eventually, the robot got malfunction. So that's the first time we're using the term of robotics in history. To define what is robotics and to cover the concept of robotics nowadays is not very easy, because robotics is a multidisciplinary research. It's come from mechanics, physics, automation, electronics, computer science, cybernetics, and AI. We use concept result from all these fields, but we are different from them. We are trying to unify 2 different cultures, namely engineering and science. By combining these 2 cultures together, we are trying to explore lots of things like autonomy, learning, consciousness, free will decision-making, freedom, emotion, and many other things. Before give you the answer on my understanding of robotics, I will go through the taxonomy of robotics. Just say what exactly we are working in the field of robotics first. We got many different applications of robotics. We got humanoid robot with artificial mind, artificial body. We got advanced production systems such as industry robotics. We got robot servants. We built that for elderly people in my project. We also got network robotics, cloud robots, and we have outdoor robotics for land, for sea, for different kind of open spaces. We have many robots work in the healthcare project to improve our life. We have military robots, we have educational robots. So we start with the taxonomy of different kind of robotics. Among so many different applications of robotics, I will pick 3 key applications: industry robots, security robots, and service robot. With these 3 kind of robot applications, we try to understand what is actually the problem we are solving. What is the difference between robotics and, let's say, automation? I'll start with the first one, which is industry robotics. The driving force of industry robotics is helping us to make better production, replace human in the dangerous, heavy, boring environment, let's say. And with industry robotics, you have many different applications. In the diagrams here, you can see that we have the ABB welding robots. This is helping us to make the panels. On the right-hand side, we got KUKA robot arm. This is used in the car manufacture plant. For most of these industry applications, you have your industry workspace, and robot is there to perform difficult tasks, which is not easy for human. And for the issue we face with industry robotics, is about we need to do research on adaptation, configuration, even the environment is not changing a lot, but we still need to adjust the robot to handle the task to optimize our applications. The industry robotics are most well-deployed robotic applications nowadays, and it's actually producing a lot of real-world application for us. Moving on from the workspace of industry process, we move to the next one, which is security robotics. For security robotics, we are mainly working in outdoor environment. So we are not have the luxury of predefined workspaces. You got a lot of unstructured environment. You're not predicting all objects around the robot, and the robot need to perceive the environment and understand the environment. On the right-hand side, you can see this is a Summit robot from Robotics. We use them for remote assistant and civilian. On the right bottom side, you have the robot called Sports. This is from Boston Dynamics. I think in Singapore, they use this robot to deploy them in the park. If someone not taking his face mask, the robot will give notification directly to the human over there. And in this slides, we will see for security robot, the main challenge we are facing is about situation awareness. It's understandable because we are working in a more challenging environment. We cannot fully define the environment like the industry robot. I got 3 more examples over here. And this is a Curiosity from NASA. It was a Mars rover we have been sending into the Mars a few years ago. We know this month we got 3 further robots sent to Mars. One of them is from UAE. And then we got the rescue robot in airport and rescue robot in caves, helping us to detect unexpected situations. So that the second category robots I want to show you. The third category of robot I want to show you is service robots. We're moving from outdoor to indoor. Robot is working with human in the indoor environment, helping us to improve our quality of life. Compared to rescue robot working in outdoor, it's actually getting even more challenge now because the indoor environment is not only unstructured, but also with lots of dynamics. You have to work with safety. You have not to damage anything in the environment. You need to ensure that the robot would be able to keep the surrounding environment in a safe place, not to hurt humans. And on the right-hand side, we have a Locomat and the Reharop robot. These two robots is designed for rehabilitation. So the people can work in the robot and then to do the recovery from injury. And also in this picture, this is show our robot deployed in an elderly care home. And the robot will fetch the medication to elderly people and then give them medications, food, and water for them. The main issue, as I mentioned, is about autonomy and safety. Robots need to be clever enough to handle different kinds of situations, plan for themselves, and maintain the consistent performance in the unpredicted environment. So that's three kinds of a robotic system we normally face in real life. And for the service robotics, there are many different kinds of challenges. And we need to deal with complexity and improve machine learning to deal with unexpected situations, optimize the sensors especially in unexpected situations. Coming together, going back to my question, what is robotics? Compared to automation, what is different from us? You can see from the line of example we have been presented so far. Robotics is about handling unexpected situations. We're trying to build intelligent machines to make its own decision in different kind of unstructured and dynamic environment, from industry process to rescue outdoor environment to indoor environment with human. More and more challenge will be faced by robotics. It requires different disciplines to work together, from computer science to engineering, even from psychology to human science, to work together to deliver the optimized solution with human beings. To build robotic applications, we have something called ROS. ROS stands for Robot Operating System. This is a universally accepted programming environment for us to developing robotic applications. The main challenges faced by us for ROS application are three. The number one, we are facing a world which is asynchronous. What we mean here is that there is no dedicated sequence on task execution for robot. For example, if you have a robot which is detecting object on a table, you cannot guarantee that there's no other things happen to the robot. Maybe another intervention which reaches the robot has to stop and handle another task before it going back to the detection. This is not going to be predefined as a synchronized task. So you have to deal with asynchronous for robotic tasks. Second, robot must handle significant amount of complexity. This is obvious. We have a different kind of robotic system already described in the previous session. And third question we are facing It's about there are many different kind of robotic systems. There are many different kind of hardware. We have for robotic applications. So to actually develop robotic applications, we need to be able to handle different kind of hardware, different kind of software, different kind of complex tasks in an asynchronous way. So this is my applications in the lab. What we want to do is that we want to have some kind of big software which can, using very simple platforms, test our application scenario and then redeploy them into complicated hardwares into a real robot. We want some kind of architecture to support us to build this kind of complicated hardwares from simple platforms. For ROS, the objective and it's same as software engineering. It's about reusable code. So for simple platform we developed early on, we can redeploy them into different kind of robot. No matter this is a carol board, this is a small Roomba, or this is a PR2. They share similar kind of architectures. They share similar kind of controllers, similar kind of software logic we can implement in our laboratory first. Compared to computer, to PC and smartphone ecosystems, we have standardized layers in our computing industry. They got system software, they got abstract of hardwares, they got different kind of application levels, and they got many different libraries. Altogether, this is illustrated in the diagram on the right-hand side. So underneath, you got hardwares, and then we have a system software. We got application building blocks, and finally, on the top of that, we got applications. So this is what we use in software engineering, in building application software in our PC or smartphones. Same approach will be applied into the robotic ecosystem. What we do is that we integrate the application building block and system software together into ROS. And then we have a hardware and our applications glued together with robot operating system. It's kind of like meta operating system. ROS is open source. It runs mainly on Linux, especially Ubuntu. It can run on Windows, but it's not optimized yet. It is agent-based, and we got distributed message passing, just like normal distributed system. We support publish, subscribe, and then we have different kind of services using remote method invocation. Finally, different kind of programming language will be supported by the robot development using ROS. No matter you are C++ people, you like Python, or you prefer Java, they will be integrated together into the robot development. At the same time, ROS is a package management system. What I mean the package management, it means that it will manage different kind of component for you in terms of your robot. In the diagram over here, we show a PR2 system. Inside the PR2 robot, you have thousands of different packages, each of them handling a specific task like navigation, detection, or perception. All this package with different versions coexisted inside the robot. They are managed as a package by the ROS. So that like a coordinating system for you to maintain the consistency of your package inside your system. This software is founded by Velo Garage. They have exponentially adopted by the robotic field in the last decade. There are many different kind of robots use ROS. You can go to the web page, you can check hundreds of different platforms already been adapted with the system. The key philosophy of building application with ROS-based robotic application are hardware independent, peer-to-peer, tool-based software design, multilingual support, lightweight, is free, open source, and suitable for large research and industry to have the scalability and transparency. A lot of things, if you come from software engineering background, you see lots of similarity in terms of building robotics software and building software application for software engineering. Start with the hardware independent. As we mentioned, no matter you are working on the application side, you are working on the hardware side, we will be linked together, glued together by roles, and then roles will be working on the abstraction. Those abstractions help you to integrate other components together with your development. For example, if you're building your navigation application using Turtlebot, a very simple robotic platform, you realize that there is a nice new visualization tools come from MIT. There is another fancy tools which is come from Stanford University for SLAM. With ROS, you can simply integrate those components together because they follow same kind of abstraction. Similarly, for hardware developer, you can have your own camera, you can have your own platform adapted to the abstraction, so you guarantee no matter you're working on Carabot, you're working on Turtlebot, or you're working on Summit XL, different kind of platform, they have same kind of interface. They will be integrated into your control software later on easily. For ROS system, we mentioned that it's based on the idea of distributed system. So it follows something called peer-to-peer messaging. We got something called a master. This is to handle the name resolution, just like what we have in the DNS in the internet. So all the package can publish and subscribe the right content in their interest and ensure the delivery of their services inside the robotic system. There is no centralized server inside the ROS. This master service helps you to look up the topics around the robot. This ensures the unsynchronized data streaming among different nodes inside your robot systems. There are many different tools made by ROS, and these are used for the software design. You can build different nodes using ROS tools. You can view the tokenology. You can see the network traffic inside your robot, and you can cooperate different components using the tools together. And also because they are message-based, they are distributed, so it doesn't matter what programming language you use in your own node, as long as you maintain the interface and define your message header to interpret your nodes with other applications as needed. In this example, so we can have our laser scanner built with Python, and we can have our map services built using C++. They both follow the same kind of message for the interface. They would be able to exchange messages among each other. ROS is lightweighted. So the idea of ROS is trying to integrate different kind of open source software together, such as a vision library from OpenCV, Point Cloud library, TensorFlow, OpenRIB. All this kind of library will be integrated together using ROS as an edge for them to be integrated into your component system for fast development and deployment. Yeah, as I mentioned, this is free and open source. Many open source applications nowadays, it helps the deployment of this project to be accepted by many different developers. They give us a lot of nice tools for debugging the applications. In this case, we have our camera, 3D camera, recognizing the object in the middle, and then using our laser scanner to scan the surrounding environment. This experience will be recorded in a logger, so next time you can play back the logger instead of this real robot. And that will enable you to test your own algorithm without real hardware in front of you. ROS got many different kind of visualization tools. The idea for those visualization tools is for you to see what is actually seen by your robot, what is actually perceived by your robot. So in this diagram, you can see that we have my robot deployed in front of table. And the table got a few cups and the board on top. This is actually the picture inside robot's mind. So we use that to debug the behavior of the robot to make sure that our algorithm is consistent. What is it designed for? There are many different kind of transformations used in the robot. One robot would consist of like 100 different kind of coordinate systems. So if you have your perception interpreted by one coordinate system, ROS will help you to transfer that from camera to base, from base to arm automatically. This makes life much, much easier for you to developing your robotic applications. We have many different kind of packages. I use this package example here for perception. We got OpenCV for object detection. We got Kinect, OpenNI for human sensing. We got Point Cloud Library for 3D point perception. With all of this, we have many new capability enabled by ROS. I'm going to talk about a project we built with robot using ROS system. This project is sponsored by the European Commission, and we got 6 million invested for this project. What we're trying to do is that we're trying to build a semi-autonomous teleoperated robot in elderly care center to help our elderly people. And our control interface will be intuitive. They're designed for family member to visit their elderly parents remotely. This is shown in the diagram we have over here. We started with our hardware platform. The hardware platform is come from Fraunhofer Institute. And on the left-hand side, this is our robot with one tree and one arm. If you strip off the case on the right-hand side, you can see this is a real robot inside. We have many sensors with 3 control pieces, 3 computers inside, and 1 touch screen, 1 arm, and 4-wheeled omnidirectional locomotion, and batteries, and cameras. The height of the robot is about 1.4 meters. And the reason we designed the robot in this height is that we do not want people feel in danger, feel pressure with the robot. And based on our user study, this is okay. This height is kind of user-friendly. The weight of the robot is not light, it's 150 kilograms. We have different scenarios designed for the robot and about fetch and carry, emergency assistance, and taking difficult objects for elderly people if they are too high or too low, maybe too heavy. And the robot will be used by family member, elderly people, and professional tele assistants. This is one of our user interface. This is a few years ago. We designed the user interface for iPhone, and the user would be able to specify what they want, where are they, what are the locations through the user interface, and then robot will fetch the object for the user. This is another user interface for family member. So this is based on iPad. They can help their elderly parents ensure they take their medication on time, and they can see what is happening with their family elderly parents. You can see I'm standing over here. That's a younger version of me standing on the right-hand side of the picture here. And finally, we have a professional teleoperator interface. This is for professional carers to control the robot and helping user. what we did in this project is that we designed a high-level control frameworks based on ROS. And in this control framework, we process the input from user. They can either come from a professional user, family member, or even elderly people through their smartphone. And then inside our control framework, we got brain of the robot for proactive planning. We got cerebrals in the robot for like small brain of the robot. This is for low-level control for reactive coordination. And that is the control framework we have designed. This one we got the best paper award a few years ago, and for optimizing the task to be delivered in the robot. And inside our control framework, we actually implemented something called Semantic Framework. They help us to reason what would be actually implemented by the robot. We're using semantic web technology to translate the task into the planning of the robot. You may ask me why this is so complicated. Why do we need to do that? So this is a typical task our robot do, like fetch and carry to get milk. The sequence of our robot to do that is move near to the table, detect the milk box, move to a reachable position for grasping, grasp the object, and then move back to the user. So this is the sequence we know robot would do to help us to fetch the milk. But the problem is, why should the robot move to the table? Which table should be the right table? What is the near table? How can we define the reachable positions? Why do we need to grasp? And all these kind of questions, there are many, many of them. It's straightforward for human being. It's become impossible for robot. We have to define the semantic web, define the knowledge base to actually enable the action planning to deal with the different kind of situation we have over there. You may probably ask us, why do you write that directly in your program? You just write in your program, okay, if you have a task about fetching milk, you just say move to the table first, detect the milk box, and move to a reachable position, grasp, and then move back to user. The sequence on the left-hand side, we can write that, hard code that into our robot. But in real world, it doesn't work because we have many, many environment uncertainties in our situation. You may have a new milk box. You may have a new room in your house. You may have a human walking around. All these kind of situations are called uncertainty in the environment. We have to handle the uncertainty with our semantic task planning, with our control framework. Fortunately, with ROS, with hardware platform, and with latest development on AI, we can translate all this kind of knowledge into a probabilistic way without pre-definition of the sequence. And the robot would be able to reasoning about the best possible for performance based on their real experience. So this would be the one fundamental difference compared to automation and robotics. For automation, you know what to do before the robot send out to, before the machine send out to the end user. For robotics, we don't. We only define the logic for the robot. The robot need to learn after deployed to the end user based on their principle designed from our side, like the framework we have in the previous page, and then they will learn on their experience to deliver the task. This is a simulation environment we have for our robot. And the robot is working in the simulation environment to practice themselves to fetch object for different kind of purpose. The simulation environment is actually enable us to actually see what is inside robot's mind. it helps robot to perceive different kind of possibilities. And as a developer, we would be able to understand the logic of robot using the simulation and then to improve our control program later on. Finally, our robot has been evaluated in Stuttgart, in Milan, and we have different kind of evaluation videos published. You can check that on YouTube. So this is one of our YouTube video for our robot test in Stuttgart. And I cannot play this video with you because this is a webinar, but you can just go to YouTube. This is available for you. And overall, today, very quickly, I go through some significant idea. What is robotics nowadays? And what is our approach on building robotic applications with the framework called ROS? And finally, how do we do that in a software called SRS? So my presentation is completed now and it's ready for you now. So you can send your question to us and we will try to answer you later on.
Good evening, audience. I'm going to introduce you the MSc programs offered at Majan College. These are the programs provided by the University of Bedfordshire, offered at Majan College. So we have under computer science, we have 5 pathways. The first one is computer security and forensics, then information management security, applied computing and IT, computer working, and mobile computing. We have been running MSc program since 2011. You need to study the program for 2 years, that is 4 semesters. And schools are only at the weekend, 5 schools per semester, which are kept almost once in 3 weeks or once in 4 weeks. You have a blended learning format and your degree is awarded by the University of Bedfordshire. So we have 2 intakes per year, the first intake for September and the second intake for February semester. Enter requirements for the master's program is minimum of 2.2 GPA or a good classification and IELTS 6.0. For the current semester, that is September 2020 intake, the deadline for the application is August 31st. So you can contact for more information to pg.admissions@majancollege.edu.om or the toll-free number which is provided here. So now I'll hand over to Sadiq to speak about the undergraduate programs. Over to you, Sadiq.
I think Sadiq has issues with his mic, so I can take over. So at the undergraduate program at Majan University College, we have 3 programs, BSc Honors and Diploma in Higher Education Computing, with 3 pathways, Software Engineering, Banking Information Systems, and Oil and Gas pathway under computing. We are providing in 2 modes. One is the regular mode, like any other program. One we have for the on-off. This is particularly for the employees in the oil and gas sector who works in deserts and who are not around for about a month and then they get off from work, so they can study in the block mode and they can study double to the normal student. It's like a part-time delivery, but they have classes for a duration of 1 month and then they don't have classes for a duration of 1 month. Apart from the computing program with 3 pathways, we have Computer Internet Applications program and we have BSc Honors and Diploma in Higher Education in Networking program. The mode of study is both full-time and part-time, and we do provide BSc Honors, which is a 4-year program, and Diploma in Higher Education, which is a 3-year program. Normally, the program is structured like 30 modules, Each module is having 15 credit, and then we have a total, we have technology project, which is double the credit of a normal module. So the total credits in bachelor's are 480 credits. We do have professional affiliations as the logos are represented here with ISACA, with Cisco Net Academy, with Oracle, with SAP Next Gen. We also are a member of Advanced HE, which is a UK body for professional teaching practices. And then we have Microsoft. We are Microsoft IT Academy as well.
Yeah, can you hear me, Ijaz?
Yes, I can hear you.
All right. Thank you very much for that. Yeah, for applying into this program, for these programs, there are again 2 intakes in a year. One is in September and the other one is in February. So you may also contact us throughout from this current month, July and August also. The college is open to communicate with you. The entry requirements are General Secondary School Diploma, Tanaviya, or 12th standard or equivalent. We also have APL, Accredited Prior Learning. So if you're studying in other colleges with some modules completed, you can also join here. So there will be mapping of module and you can get into the UG program according to the UG test and APL test. The contact number is here, which is 24730-409. You can also send us an email to studentoutreach@majancollege.edu.om. Our toll-free number, again, it is 80071 000. So please get back to us. Thank you very much. Kumail, over to you.
Okay, I got my screen back, and if you got any questions on robotics, you got any question on building robotic applications, I'm here to answer your questions.
Dr. Renxi, if you could look at the questions I referred to you in the questions menu, there are 3 to 4 questions for you.
Okay, let me just go through the questions. I don't really get
I can help you, Dr. Renxi. The first question is, please can you explain the concept of reusable code? That's the first question.
Okay, and the reusability of software has been the central for software engineering for many, many years. But for our field of robotics, and we have facing similar problems. The issue we have over here is that you may have your PhD in the field of, let's say, machine vision, and then you build your applications, you build your algorithm, which is very nice for potential applications. However, I have never got that PhD. I don't understand the fancy technology in that field. I have my robot. I want to use your algorithm, use your machine vision algorithm directly in my robot. What can I do? I have 2 choices. One, I have to learn. I do my PhD in the field, read your paper, understand your knowledge, and then implement your algorithm in my robot. This is not the way we prefer. We want something easier. And then this is why the second approach we adopted in the ROS. We have the abstraction. We structured different components, no matter they are software or they are hardware. As long as you have your algorithm delivered in a similar way as we defined in the ROS protocol, I'm going to use the algorithm in my platform, in my mobile robot, even I don't understand the principle of that algorithm. So I get the result. This is very important for developing robot software because you may face many, many different problems at the same time. To test your own idea, you have to get knowledge from many different disciplines. To address this issue, we have this reusability of the software introduced, And that would help us to make sure all these kind of issues can be addressed in our way. So that's
Okay,
my
yeah, the second question is, how much success have we achieved in autonomous robot surgery?
This is a very good question. You actually tackled two different things. One is autonomous robots. The other one is surgery. I have to say that robot in surgery has been fairly successful, especially with Da Vinci robot. I have this picture in my presentation. And we have doctor using robot to operate their operations with mixed reality. So they can see things they can't see directly with the patient. With different camera altogether, they can perform the task. And also robot help doctor to perform better because we can compensate the movement of a doctor's hand and then make sure they are following the trajectory. So this is very successful. However, when we are talking about autonomous medical robot, we have another issue, which is legal issue. If something fails, who is going to take the responsibility of that failure? A lot of countries do not allow machine to make this decision on its own. So normally, especially with medical applications, autonomous is not really the word we want to have. So we are moving from fully controlled scenario into semi-autonomous situation now, and fully autonomous robot for operation is a long-term objective for us. And we are not only facing the technical problem, but also facing the legal and ethical problem in that field.
Okay, the next question is, please may I get the fundamental criteria of semantic planning?
For planning, we have many different ways of performing the planning, and we can do that deterministically, so we can have everything predefined. But on the other hand, if we have many different factors to be involved into our plan, so we have to define a framework for planning, and then we borrowed. So this idea is not from us. We borrow the idea of semantic web, and we implement that in our robot, mainly for modeling the factors involved in our tasks. By doing that, we can move on to the next step because we do not want to predefine all the sequence for our robot. We have the semantic knowledge base established, and then we can build our probability models based on the semantic web, and that probability model would be able to direct our model for their operation. But on the other hand, for the robot to be deployed in the real environment, robot would expand its knowledge base, its semantic knowledge base, using the structured approach. So this knowledge base will be expanded further and further. The only thing the programmer decided is the probability model and the way we retrieve the knowledge from the semantic model. So that's why we're using the similar approach for semantic web, like you search a result from Google, you're trying to find out specific solutions. You just Google that, you get your solution. We do the same inside the robot. We have our semantic knowledge, we have a pre-knowledge there, stored over there, and the robot would search inside its knowledge base and retrieve relevant information accordingly to perform the task. That's my answer for the question.
Okay, the next question is, what shall be the fate of human workforce if robots and automation take over the jobs of human? Is the usage of automation and robots are growth or destructive force to human livelihood?
I think this is a question we face a lot, and we would like to say there are two perspectives. One perspective would be, obviously, some of the workforce will be replaced by automation, by robots, and then what should we do about that? So this is kind of inevitable. With technology coming, definitely we will be replaced in certain tasks by robot. Then how can we translate this issue into a positive trend instead of a negative trend? Instead of we saying that, okay, the human just lost their job without getting paid, we should think about creating new opportunities, because robot here is help us to generate solutions. So they can give us more and more predictability. With this capability, we should do more. We should have more service generated. So humans should be able to benefit from the wealth, from the production generated by the robot, instead of punished for that. So this is probably an issue not to be answered by scientists. They should be answered by politicians. Robots help us to produce more things, help us to generate more wealth. It's about distribution. It's not the technology in front of us. And there's another aspect for this question. This is about how can we control the artificial intelligence? Because with AI alone, we have artificial intelligence beating human in a lot of games like chess, like Go. But this is under the simulated environment. What robots do is that artificial intelligence can be used to replace us in real-world scenarios. So that is a different issue we are facing. What if this is out of control? What if this is not in the benefit of humankind? There is another project called Human Mind, sponsored by European Commission. It's a flagship project. European Commission invested 10 billion euro for this project. The central topic is about ethics of robotics. How can we ensure robot would help us instead of harm us? That is a big topic. A lot of people is discussing that, and hopefully we can find the optimal solution for that. It's a very good question here. And
Dr. Renxi, the next question is, due to using of robot in our life, the human brain capacity should be suffered by too much or not?
Well, this is excellent question. We have our robot delivered to care center, and the robot is helping elderly people to do the fetch and carry. You guess what is the result? The result is a lot of elderly people go very lazy. They don't want to work. They use robot to do things which they could do, and eventually it's turned out to be bad for them. So same thing happens to us. The robot can do a lot of things, and if we rely too much on them, our capability will be reduced. I'm very good on direction myself, but when I go to my GPS, I don't do that anymore. I always rely on my mobile phone to do the navigation. So this is actually linked to the previous question. The question about ethics of the robot is not only about prevent robot to harm us in an obvious way, but also about proactively takes advantage from the robotic capability. We need to do things which we could do. We need to be benefit from the capability, but it sounds straightforward, but in reality it's not straightforward answer can be available for us. So the new generation of our robot to be delivered into the elderly care center, they are designed in a different principle. So robot is not only do things based on the command, robot would be designed to encourage human being to do exercise, to do things for as much as possible. If they can't, because nowadays we live much longer than last generation, so robot will help them, but not all the time is commanded by the people as they wish. So that's my answer for you, but I do not have a solution for that yet. There's need further research about the ethics of the robotics.
Yeah, these are the technical questions which have been posted in the chat box. The other question is about GPA. Armstrong, are we considering it here, or would it be transferred, this question would be transferred to the appropriate department at the college?
That's what we would do, Jacinta. The question is taken note of. The person who has posted the question, we would respond to that by an email. This was a question related to joining the program and the possibility of scholarship. That would be addressed by an email.
Okay, fair enough.
Thank you, Jacinta. That brings us to the end of this webinar. I'll take a couple of minutes to recognize the people who made this webinar possible. First and foremost, I would like to thank Renxi. Renxi teaches on the MSC program. He flies in. It was little over a year ago when he was here and when he was interacting with school students, the seeds of this webinar were planted. Fortunately, we could make it happen, though it took a long time. Renxi is a very active researcher. We really appreciate the time he could find for this webinar. Thank you, Renxi. I would also like to thank my colleagues who worked together to bring this webinar to you. I thank Ijaz, Siddiq, Jacinta, who are academics in Majan University College, as well as Kumail and Roshan, who lead our marketing efforts. This is the third of the series of webinar brought by our partner institution, University of Bedfordshire. We are working with them to bring few more webinars as well. So soon you would hear from us. And we believe this was great learning for you. And I will take leave with a brief quote from Daniel Wilson, who is a prominent author in robotics. There are an endless number of things to discover about robotics. A lot of it is just too fantastic for people to believe. With that note, I take leave. Stay home, stay safe, and good night.